Hi guys, so in this video we'll be discussing elasticity along a demand curve and demand curves with constant elasticity. So let's have a look at this demand curve here. So this diagram over here represents that on a normal demand curve, we look at demand curves with constant elasticities later on, but on any normal demand curve, the elasticity value varies. So when you're, let's say, on the top left corner of the demand curve or in the top left region, the demand curve is elastic over there and the value of PD is between 1 and infinity, right? Between 1 and infinity. And if you're in the bottom right corner of the demand curve, then you're in the inelastic region and the value of PD will be between 1 and 0. And there is an explanation for that as well. One part is that over here, okay, let me just go with this one and then I'll go with the explanation. So in the center it's at 1, so it's unitary elastic in the center. Now the explanation is that, let's say if we were at this point, right, somewhere around this point, and the price is, let's say, 10 and the QD is 1. So if there was a change in price, the change in price will, let's say if the change in price is from 10 to 9, right, it's changing from 10 to 9, and this is the corresponding demand 2. So the percentage change in price over here is, let me just calculate that value. So 9 minus 10 divided by 10 into 100. So that's a 10% decrease over here. So the percentage change in price is 10%. The percentage change in QD is 2 minus 1 divided by 1 into, that's a 100% increase from 1 to 2. So this is a 100% jump and this one is a 10% decrease. And if you put it over here in the formula, that is going to give you a value of 10. So the value of PD is equal to 10, which is obviously greater than 1, and so it's going to be considered elastic. And the explanation, as I told you guys right now, is that in the top left corner, since the values for price are high, right, like 10 and 9 as compared to 1 and 2 in the top left corner, the percentage changes are low. So when you move from 10 to 9, that's a 10% decrease, as compared to when you move from 1 to 2, that's a 100% increase. So let me just clear all of this up right now so we can move to the next region. Right, so the next region is the bottom right corner region, and so over here let's just assume that we have a price of 2, quantity is 9, and then a price of 1 and the quantity is 10. So if we calculate the percentage change in price and the percentage in quantity, then the values which we calculated in the first part, they will just get reversed. So over here 2 to 1, that's 100% decrease, that's like 100% decrease, and over here 9 to 10, that's a 10% increase in quantity demanded. And so we can just write 10 here and 100 here. That's going to give us a value of 0.1. So PD is equal to 0.1. Since the values in the top right corner for quantity are higher as compared to the values of price. So the values of price are 2 and 1, which are obviously small values, as compared to 9 and 10, which are larger values. And so that's the explanation for the varying elasticity along the demand curve. And then there are 3 different cases in which the demand curve has constant elasticity. So the first one is perfectly inelastic demand curve. Here the PD value is equal to 0. There is no other way to this. Just by using the same formula, we can see that, okay, regardless of whatever the price is, the quantity remains the same. The QD will always remain the same regardless of what the price is. And so in the formula, QD will be zero, and so because that, the final value will also be 0. The next one is B. So this is a perfectly elastic demand curve, and so in this case the value of PD is equal to infinity. Let's go back to the formula here. Let's just copy the formula. So if we take this formula down, over here, then we can see that um, there is no QD at any other price. So let's say this is a price of 10. People are willing to buy each and every quantity that is produced and that is available in the market. If the price was higher than this or lower than this, people would not buy even a single quantity of the given good, which is why the value of PD is equal to infinity, since this is infinity. So anything, well, obviously, since the numerator here is infinity, the final value will also be infinity. Then the next one is PD is equal to 1. This is a rectangular hyperbola for which the value of PD is equal to 1. And so this represents unitary elasticity. It's going to remain the same throughout the curve, regardless of which point we take. Rather, let's say if we want to take this point, if we want to take some other point, the value of PD will always remain constant. So that's pretty much it from this video.